Differentiations of implicit functions. The implicit functions are the functions where the x and y are mixed together in the functions. In this case, the x and y's are difficult to be separated in left and right. This commonly occurs when there is a multiplication of x and y, or when the y are of power. Opposite to the implicit function here, the explicit functions. In this case, we can easily separate the x and y at both sides. In our previous videos, all the examples discussed are in the form of explicit function. In these videos, we're going to discuss the differentiations for the implicit functions. These are some equations that can be used for the differentiations of implicit functions. You can consider it as functions within functions. In the case that you need to determine the du dx, you can actually differentiate du dy and dy dx, as if the dy and dy can be cancelled out each other. And when you need to differentiate y into dx, you will differentiate the function into dy and then differentiate dy over dx. To better understand the equations, let us try some examples related to the implicit functions. Let's say now you are asked to differentiate this 2y power of 4. For you to differentiate it, you will differentiate it over y and then multiply dy per dx. Rewrite the equations, you get this. Let's say now you are asked to differentiate this over t. You may differentiate it over t and then multiply with dt dx. Rewrite the equations, you get this. What you see here is dy dx and dt dx here is necessary because the y and t here is also a function of x. We cannot ignore the differentiations of the y over the x, otherwise the differentiations will be incomplete. Let us try another example here. You are asked to differentiate the two items here in respect to x. Knowing that the y is also in the functions of x and the data is also in the functions of x. To solve this, you will need to differentiate it over the y and then to be multiplied with dy dx. Same goes to this example. Differentiate over the data and to be multiplied with dy dx. Again, the dy dx and the deta dx cannot be ignored because both of them are in the functions of x.